Imagine looking up at the night sky and witnessing a spectacle unlike any other. A celestial event so grand and awe-inspiring that it would be talked about for generations to come. Betelgeuse, the bright red star in the constellation Orion, suddenly explodes. This massive star, one of the largest visible to the naked eye, has been a subject of fascination for astronomers and stargazers alike. It becomes brighter than the full moon, casting eerie shadows across the Earth. The night would turn into a surreal twilight with an intense glow illuminating the landscape in an otherworldly light. This isn't science fiction but a possible reality, a cosmic event that has captivated astronomers for centuries, a supernova. Supernovae have been recorded throughout history, leaving their mark on human culture and scientific understanding. But what exactly is a supernova? It's the dramatic death of a star, a powerful explosion that occurs when a star has exhausted its nuclear fuel. How do they happen, and what would be the consequences for our planet if a nearby star decided to go supernova? The radiation and energy released could have profound effects on our atmosphere, and potentially life on Earth. In this exploration of the cosmos, we'll delve into the fascinating and sometimes terrifying world of these stellar explosions. Join us as we uncover the mysteries of supernovae and their impact on the universe. Stars, like our sun, are giant balls of burning gas. They are massive celestial bodies composed primarily of hydrogen and helium, undergoing constant nuclear reactions at their cores. They produce energy through nuclear fusion, converting lighter elements into heavier ones. This fusion process is what powers the star, allowing it to emit light and heat. This process releases immense amounts of energy, keeping the star shining for billions of years. The energy radiates outwards, reaching planets and other celestial bodies in the star's vicinity. However, stars have a life cycle, just like everything else in the universe. They are born, they live, and eventually, they die. The life cycle of a star depends on its mass. When a star runs out of fuel, it can no longer support its own weight. The outward pressure from fusion reactions ceases, and gravity takes over. The core collapses in on itself, triggering a runaway reaction that releases an unimaginable amount of energy. This collapse happens in a matter of seconds, leading to a dramatic and violent event. This catastrophic explosion is what we call a supernova. The explosion is so powerful that it can outshine entire galaxies for a short period, leaving behind a beautiful and complex remnant. There are two main types of supernovas, each with a unique origin story. These cosmic events are among the most powerful and luminous explosions in the universe, capable of outshining entire galaxies for a short period. Type 1 supernovas occur in binary star systems where two stars are gravitationally bound and orbit each other in a delicate dance. In these systems, a white dwarf star, which is the remnant of a star that has exhausted its nuclear fuel, steals material from its companion star. This process is known as accretion. As the white dwarf accretes more and more matter, it eventually reaches a critical mass, known as the Chandrasekhar limit, and explodes in a thermonuclear runaway reaction. This explosion is incredibly bright and can be observed across vast distances in space. Type 2 supernovas, on the other hand, happen to massive stars at the end of their lives. These stars are typically at least 8 times more massive than our sun. When these massive stars exhaust their nuclear fuel, they can no longer support themselves against the force of gravity. Their cores collapse under their own gravity, leading to a dramatic implosion. This implosion triggers a shockwave that rips through the star, causing it to explode in a spectacular supernova. The energy released in this explosion is so immense that it can briefly outshine an entire galaxy, leaving behind a neutron star or black hole. The energy released in a supernova is almost impossible to comprehend. For a brief period, a single supernova can outshine an entire galaxy, emitting more energy than our sun will produce in its entire lifetime. The explosion sends shockwaves through space, accelerating particles to nearly the speed of light. These high-energy particles, known as cosmic rays, can have a profound impact on their surroundings. They can trigger the formation of new stars, alter the chemistry of interstellar gas clouds, and even pose a significant